Hi, my name is Mike Tamir. I'm Chief Science Officer and the head of GalvanizeU. GalvanizeU is a new venture under the Galvanize Inc. ecosystem. We've had the G School, an unaccredited code lab and boot camp, immersive programs for a couple years now, and starting this January, we are opening a fully accredited master's program that will train the next generation of data scientists. It's a Master's of Engineering in Big Data, and we're on the works for a full MSc for data science. So really quickly, I know we did some polling earlier. Has anybody in this room is directly in the field of data science or has done research with, done some hiring in the data science field? Who's had trouble with hiring in the data science field? 100% of the people. Oh. All right. So GalvanizeU is designed to address this problem. It is a huge issue, and I think that there's a convergence of themes from the last two talks. There's coming out of a master's program, coming out of a boot camp, is not the entire story. There are soft skills, there's certainly theory, there's the mathematics, the science, the machine learning, the statistics, and there's also the experience. And that was, during the question and answer period for Joe, that was a big part of it, is developing this experience, figuring out how to communicate about the data science. And it seems like there's no comprehensive solution yet. There's nothing that really drives all three: knowledge, coding ability, and experience. This is really backed up in the figures that you see about every other week. Wall Street Journal, someone publishes an article about why nobody can find this magic new skill set, this magic new, there was one just the other, a couple weeks ago, high priests of big data. Nobody can find the data scientist that can actually do the things that people want data scientists to do. And this is not going away, it's actually getting worse. There's more and more and more data. IBM published this statistic that in the last 2 years, 90% of the world's data has been created, and that statistic's a little bit old, so I'm sure it's even more than 90% by now. This is a big issue that we are primed to solve. And how are we going to solve it? There's the background knowledge, like I said. A lot of students come out of these pure coding boot camps, and they know how to pull up their Python library or their R library, and they can fiddle with the knobs on creating a logistic regression or an SVM. But as soon as you get to a point where you run into a challenge, you can't build something with your model, you're off the rails. And then these students are usually clueless. It takes quite a bit of experience to figure out what to do when things go wrong. On the other end, sometimes you'll hire a student that comes out of a graduate program. They've taken a machine learning course, or maybe they just did Coursera and took Andrew Ng's machine learning course. I get those on resumes now a lot. As I went to Stanford University, took the online Coursera course by Andrew Ng. Or Trevor Hasty and Rob Tripashari have a great one now too. Some people can learn the theory that way, but not most. And very few people learn the coding ability to do that. And so you'll come out, maybe you only know R, maybe you know a little bit of Python, but you really don't have those muscles worked out yet. You don't have all the hours and hours of banging your head because you got the errors in order to get around a lot of the problems that data scientists face every day. And then there's the third piece, and the third piece is usually something that doesn't happen before you reach the job market. It's the experience. It takes about 6 months to get someone from really brilliant machine learning trained, fresh out of grad school student to someone that can fully perform at the data science, at a high performing data science level. It's a real big challenge, and this is part of why, and after that, they get hundreds of recruiter calls on LinkedIn. Do an experiment. Put data scientist in your title on LinkedIn and see how many emails you get every morning. It can be overwhelming. After you get that experience, everybody wants you. but there's very, very, very high demand for these people because there are no people that can do all three of these things. All right, so how do we actually accomplish the theory? I think this covers a lot of what the last talk was about. And the skills list, the hard skills list, there's the theory, and then there's also the sort of working with the hardware. So mathematics, we have a baseline training that gives them all of the mathematical structures, the space. What is a vector space? What is a metric space? What is an inner product space? What are LP norms? All of the details that you have to become really good friends with if you're going to be manipulating these data sets underneath. Getting a nice conceptual feel for where these data frames live and what sort of vector spaces you're manipulating. A lot of people that come out of the coding boot camps just don't have that. They haven't developed those intuitions. They never went through the training for it. So it can be very hard when something goes wrong to figure out why it's going wrong and what sort of techniques can be used to fix it. So we create a baseline with that. Same with the statistics. Hypothesis testing, probability theory. What is a distribution? It takes a little bit of thought to figure out the difference between a distribution, which is a continuous function usually, it's a bounded continuous function, and a random variable, which is not continuous at all. And knowing in your gut, getting that in your blood, what the difference between these concepts are, how they work, is a big part of being the kind of high-performing data scientist that people are looking for. And then there's, of course, the machine learning, not just the statistical modeling, but building the statistical learning algorithms that can actually do the classification, the regression, the clustering, the dimensionality reduction, that are the bread and butter of building prescriptive and predictive models. We have quite a bit of this in the curriculum, at least 2 full courses, so not just the basics that you might learn in an online Coursera course, even if you're brilliant enough that you don't need any hand-holding, but the more advanced stuff that you can't get anywhere, maybe only if you do the advanced research or journal research. And then, of course, understanding the math that the data is living in is only part of it. There's also being able to work with the data, to manipulate the data, understanding massive parallel processing, map-reduce paradigms, all the tools that are out there, Spark, H2O, Deep Learning 4J, RDMEMS spaces, how to access APIs, what that's like using relational data querying and non-relational data objects, like JSON, and the list goes on quite a bit. All right, so that's the theory, but just knowing the theory is only one piece, it's a huge task, but it's only one piece. There's also getting your hands dirty. So we have every day open lab hours where students are going to work on their daily exercises under the supervision of TAs and the lead instructors. And this is, you got to lift the weights if you want to get those muscles stronger. And so we have lots and lots of time working with real-world examples that come from our Galvanize members. Let's take a step back about what the larger Galvanize context is. We have these campuses we have 3 active now, and we're on a roadmap to opening a number of other ones. This is a community space where member companies come in. They come in, some of them are large. IBM has an office in our San Francisco campus. Some of them are smaller, maybe just 1 or 2 people with a great idea. At the San Francisco campus, we have 700 member companies who come in there almost every day to work on their projects. And this is a huge ability for us to tap into real-world data science problems. Data science, the access to data and what you can benefit from data, sometimes people ask, that's just a technology problem, and it really is not. It's more like having, saying something like operational excellence is not an important thing for most companies. It's only an important thing for manufacturing. It's a skill that, or it's a tool that any company can use, and that a lot of companies aren't using. The healthcare sector could really, really benefit from being able to analyze and deal with a lot of the private data that's being worked on now. Everybody has a phone. I can tell you from experience in previous roles that there is a lot of data every one of your apps has access to that they can benefit from. That's an easy one. It's in the technology field. Working with any sort of system or any sort of industry application where you have access, a lot of touch points to random variable sources. You can benefit by seeing how to break that down, what you can expect. Any sort of business model where you don't know what's going on in the future, you can benefit from these. And maybe you can't benefit by hiring a new data scientist, which is really expensive and really hard to find. But if you bring it into the Galvanize campus, then we have this access to dozens of Galvanize students who are able to work on these projects and help you to find the solutions. And this benefits everybody. This benefits the Galvanize members, but it also benefits the students because they get to get their hands dirty and they get to do it under the supervision of experienced practitioners. All right, so getting back to the main piece, and this is something that I think nobody really has gotten the recipe quite right yet. The paradigm for teaching data science, and this is a job title that didn't even exist 3 years ago, is you get the coding experience from somewhere, maybe you get it in a computer science degree or in the course of a coding boot camp. You get the theory, if you're lucky, by going to a master's program that's going to give you the opportunity to learn about the machine learning, all the important mathematics, all of the statistics, the hard statistics. And then you go into the field, and that's where you get the experience. This is analogous to how, to training doctors and saying, okay, spend a year with us, we'll teach you anatomy, and then go be a doctor. And it's a foolish sounding training program, right? It's not gonna get you, nobody coming out of med school, people coming out of med school still do their residencies, but even in med school, you spend like half your time actually in a hospital, shadowing attendings, watching actual doctors practice medicine and learning from those observations. And this is one of the guiding philosophies for how we're creating the curriculum. The students are gonna get the theoretical training, certainly. You can't be a doctor without the anatomy. And you can't be a doctor or can't be a surgeon. That was a great example earlier, unless you actually have the dexterity, your fingers are ready. But you also can't be a surgeon unless you've actually done surgery. That's how you learn how to be a surgeon. And this isn't good, not just with maybe dexterity, right? You have to do it on the being a surgeon, a brain surgeon especially, that takes years and years of working under the supervision of attendings that can train you. But it's also, there's also just observing bedside manner. How do you learn how to be a good doctor and how to have good bedside manner? You watch the attending walking around, treating the patients. And this is part of the soft skills that really don't get developed. So, so each of our instructors, each of our faculty members is actually going to be practicing their profession. Just much like in a teaching hospital, the doctors don't just teach med students, they also practice. And so we're gonna have, with each of the member companies, with the business partners, we're gonna have this consulting opportunity where the faculty member will be mentoring a handful of students and will allow them to shadow the faculty member while they're meeting in Galvanize campus with clients, learning how to listen to a problem. It can take quite a bit of effort. It takes a lot of skill to listen to someone saying, well, I have some data and I kind of want to do this, but I'm not quite sure what it is. And learning how to turn that into a concrete problem that can be solved with machine learning or statistics it takes a while. And it's something that really, a skill that can only be taught by practice. You can give some of the background theory, but can only be taught by practice in the end. Learning how to listen and also learning how to communicate back to a technical audience, but also more importantly to a non-technical audience. Someone said CEO, you can have a CEO of a hospital that has never been a doctor, and that's true, but you need to figure out, the doctors need to figure out how to talk to that CEO if they're gonna need to make a request and need to do something that's important, going to benefit the hospital. So we're gonna focus on learning how to treat the business problems and turn them into data science solutions. And as the trainees' skills grow, especially towards the end when they've already gotten as much or more of the theoretical and coding ability, but haven't quite figured out those soft skills. They're going to be able to practice more and more, much like a surgeon. As they learn the theory, we go in through the shadow end, and they start to be able to do maybe appendicitis is one of the early ones that becomes very easy. And we're going to have this similar sort of approach with our students. So these soft skills, and we also have dedicated class time for that. We have a part of the curriculum. A core part of the curriculum is data science, communication, and visualization skill, where you learn the theory of how to present data in graphs and visualizations, and how to interview with a client, and how to communicate with non-technical language, what it is you actually want to do. All right, so that's short. I'm sure there are some questions about exactly how we're going to get into this, and I'm happy to answer them. So our applications are opening this Wednesday, the 29th, and anyone interested in joining the faculty, please email us.